In this video, we're going to look at how to evaluate unknown angles using your half-angle identities. So this requires you to draw triangles again. Okay, so for number one, you're given that the sine of u is 5/13 and that pi halves is less than u is less than pi. Okay, so first of all, the sine is positive. Sine is always positive in quadrants 1 and 2 because it's the y value. So we know we're in quadrant 1 or 2, but then this right here narrows it down for us. If we have to be between pi halves and pi, that means we're between 90 and 180. So we're in quadrant 2. Go ahead and draw you a triangle. In quadrant 2. So that's u. Okay, we're told that the sine is 5/13. Sine is opposite over hypotenuse. So you know where your 5 and your 13 go. We're also going to need that third side. So go ahead and do the Pythagorean theorem, or you may recognize that that's a triple. 5, 12, 13 is a triple. So this side's got to be 12, but since we're going left, it's got to be a negative 12. Okay, so we're asked to find the sine of u halves, cosine of u halves, and tangent of u halves. So let's start with the sine of u halves. Now, this is the formula we're going to use, but before we start, we have to know if we're going to need the positive or the negative. So think about this. U is in quadrant 2, which means u is between 90 and 180. We're finding u halves, so we're finding half of something that's between 90 and 180. So if you take the lower limit, which is 90, and half that, that puts you at 45, which is in quadrant 1. If you take 180 and you half that, that puts you at 90, which is the end of quadrant 1. So you know that u halves is somewhere in quadrant 1. And sine is positive in quadrant 1, so we're going to use the positive again. All right, so we have 1 minus cosine u over 2. All right, the cosine of u is negative 12 over 13, adjacent over hypotenuse. So we have 1 minus negative 12 over 13, all divided by 2. That double negative can be made into addition, so we have 1 plus 12/13, all divided by 2. And then what I would do from here is we have a fraction within a fraction. We want to get rid of that 12/13 by multiplying everything by 13. All right, if we multiply everything by 13, that means the 1 becomes a 13, the 12/13 becomes a 12, and the 2 becomes a 26. Okay, so what we really have here is 25 over 26. And that works out nice because 25 is a perfect square. So the square root of 25 is just 5. So I can take the square root off the numerator, but I'll have to leave it in the denominator because 26 doesn't have a nice square root. And then you'll want to rationalize that out because we can't leave a square root in the denominator. So if you multiply top and bottom by square root 26, you get 5 square root 26 over 26. So that's the sine of u halves. Okay, now let's do the cosine of u halves. Same formula, except we change this to an addition, and we also have to make sure and decide whether or not our sign is positive or negative. So we said that u halves was in quadrant 1 somewhere. Quadrant 1 always has a positive cosine, so we're going to use the plus, which means you don't have to write it. Then we've got 1 plus cosine u over 2. All right, so 1 plus cosine is negative 12/13, all divided by 2. We know that that plus a negative is really going to become a minus. So we have 1 minus 12/13 over 2. Go ahead and multiply by 13 just like we did over here to get rid of the fraction within a fraction. So the 1 becomes a 13. This just becomes minus 12, and then the denominator becomes 26. 13 minus 12 is just 1. So we have the square root of 126. Well, the square root of 1 is just 1. So we can take the square root off of the numerator, but we do still have the square root on the 26. And then we're going to rationalize that out, which will give us square root 26 on the top and just 26 on the bottom. So that's the cosine of u halves. And then when you get to tangent of u halves, you can use your tangent formula, or since you already have sine and cosine, you can just divide those out, which is what I'm going to do. So we have 5 square root 26 over 26 divided by square root 26 over 26. And remember that these 26's in the denominators are going to cancel. So we're left with 5 square root 26 over square root 26. And those are going to cancel. So our answer is just 5. So that one actually simplified really nice. Let's try one more. Okay, for this one, we're given that the cosine of u is negative 4/5, and pi is less than u is less than 2 pi. And then we want to find the sine, the cosine, and the tangent of u halves. So if you'll pause the video and see if you can draw your triangle and get it set up correctly, and then turn the video back on and check. Okay, so we're told that the cosine is negative 4/5. Cosine is always negative on the left side of the unit circle since it's your x value. So that'd be quadrants 2 or 3. Okay, quadrants 2 or 3. Well, which of those two quadrants falls between pi and 2 pi? If you're greater than pi but you're less than 2 pi, you're in the bottom half of the unit circle, which would be quadrants 3 and 4. So we're going to have to go with quadrant 3 on this one. So if you draw that out, and you're told the cosine is negative 4/5, that's adjacent over hypotenuse. So the negative 4 there, and the hypotenuse is 5. You're going to need to find that third side using the Pythagorean theorem, or if you notice that it's a triple, 3, 4, 5 is a triple, so this side's got to be 3. But because it's going down in quadrant 3, it's going to be a negative 3. Okay. So let's look at finding sine of u halves. All right, so let's think about what quadrant u halves would be in. If u is in quadrant 3, that means u is somewhere between 180 and 270. Okay? If we half any of those numbers in there to get u halves, where would they fall? So the easiest way I think to do that is start with something small and something large. The smallest thing I could half would be 180. Half of that's 90. The largest thing would be 270. If I half 270, I get 135. Either way, I'm falling right in here. So half of u puts me in quadrant 2. So I'm looking for a quadrant 2 answer. Sine is always positive in quadrant 2, though. So I'm going to use the plus here. All right, so I have the square root of 1 minus cosine u over 2. All right. What is the cosine of u? The cosine of u is negative 4/5. All right, so this becomes 1 plus 4/5 over 2. I want to multiply everything by 5 to get rid of that fraction. So that makes the 1 a 5, that makes this a 4, and that makes the denominator a 10. So I have the square root of 9/10. The square root of 9 is 3, so I can go ahead and take that. The square root of 10 is not a nice number, so I leave that. And then I'm going to rationalize it out. Multiply top and bottom by square root 10. So in the numerator, I get 3 square root 10. And in the denominator, I get just 10. So 3 square root 10 over 10 is my answer. Now let's do cosine of u halves. All right, we said that u halves puts us over here in quadrant 2. Well, in quadrant 2, the cosine is negative. So this time I'm going to use the negative sign when I work out my cosine formula. So negative square root of 1 plus the cosine of u over 2. So we've got negative square root 1 plus negative 4/5 over 2. Just going to simplify that plus a negative into a minus. And then again, multiply everything by 5 to get rid of that fraction within a fraction. So this becomes a 5, and this becomes a 4, all divided by 10. So we have negative square root of 1/10. All right, we know that the square root of 1 is just 1, so our top just becomes negative 1 over square root 10, and then rationalize that out. So we get negative square root 10 over 10. All right, and for tangent. Now let me stop here just for a second and explain why we've been drawing the triangle when we technically, I guess, don't need it for sine and cosine. We never used this 3 that we found as the third side in these two formulas because both the sine and the cosine formula rely only on cosine inside. So we could do the sine and the cosine both without ever having to use this third side here that we weren't given. But I usually go ahead and find it anyway because some people, when they get to tangent, like to use the formula rather than doing sine divided by cosine. And if you're going to use the formula, you'll need to know sine anyway, and so then you'll need that negative 3/5 opposite over hypotenuse if you're going to do it that way and find the sine. So it's good to go ahead and have the triangle drawn, even if you're not using everything in it, because it gives you a good visual of what you're finding, plus it helps you with those tangent formulas if you're going to practice using those. But again, I think doing sine divided by cosine is easier, so that's what I'm going to do here. It's 3 square root 10 over 10 divided by negative square root 10 over 10. All right, and then those 10s on the bottom are going to cancel. So we get 3 square root 10 over negative square root 10. Then the square root 10s are going to cancel, and your answer is just negative 3 for tangent.